Hey everyone, let's take a look at the equations that we learned in a previous video. We still have the same beam here. And one of the things we discovered was that the shear force in the beam between A and B, so for any position less than 8 meters, that would be anything left of B, that's equal to minus 3125 newtons. And we found the moment in that same region was minus 3125 newtons times x, whatever that x distance is, as long as it's less than 8 meters. The other thing we discovered was that from B to the end of the beam, so between 8 meters and 10 meters, we discovered that the shear force at that location was 125 newtons. Positive 125 means it's pointing down. And then 125 newtons x minus 1250 newton meters, that was the moment in that region. All right, so the shear force and the moment have changed at that region. One thing that I'm interested in though is what is the moment at 8 meters, right? Because this is x less than 8 meters, and this is 8 meters less than x less than 10 meters. And I want to know what's going on at that location. And what I discover is if I take minus 3125 newtons and I multiply that by the 8 meters, in other words, at x equal to 8 meters, I get negative 250 newton meters. So I'm using this equation and I'm substituting in 8 meters. But I want to do the same thing for the other equation. I'm going to substitute 8 meters into here. So I get 125 newtons times x minus 1250 newton meters. So 125 newtons times 8 meters, but that's 1,000. And 1,000 minus 1250 newton meters leaves me minus 250 newton meters. Notice the moment is continuous at that location, right? The moment is the same at that location. Now the shear was not. The shear went from minus 3125 to positive 125. Why did it change? What made the shear not continuous? And what makes it change is the fact that there's a force applied at this location, at point B. And that force is negative 156.25 newtons. That force forces, if you will, a discontinuity in the force function. So when I go to graph the shear force function at minus 3125, right up until I reach the 8 meters, and then I pop up to 125 newtons at that 8 meter mark until I get to the end, and then it will drop back down to 0. Okay, so there's a discontinuity there. But if I look at the moment equation, I get the moment for the first 8 meters is minus 3125 newtons times x. So that's a straight line going downward slope. So I have minus 3125 newtons, and then at this location it's equal to negative 250 newton meters. But when I go with the next equation between 8 and 10 meters, 125 newtons times x, so that's going to be a positive slope. And when I go to 10 meters, I get 1250 minus 1250, which is 0. And so it slopes up to the 10 meter mark where it goes back to 0. But the function is continuous. The derivative of the function is not continuous, right? But that's the shear again. The derivative is not continuous, but the function is continuous. That's because there is not an external moment being applied at point B. There is an external force being applied at point B by the roller. There's a force due to the roller acting on the beam, right? The normal force. So that's an external force, and that causes a discontinuity in the force function. But there is no external moment acting on the beam at 8 meters, and so the moment equation has to be continuous. All right, now if there was an external moment applied at B or anywhere else, then the moment equation can become discontinuous. The internal moment, I should be more specific. So the internal shear force function, not continuous because of the external force acting at B. But the internal moment function, there is no external moment, so the internal moment function is going to be continuous. All right? All right, next video or future video, I'm going to go to a system where the equation's a little more complicated. Okay? or the forces are a little more complicated, and we'll take a look at that. All right, if you have any questions on this, please leave them in the comments below. Thank you.